You are most welcome to our chemistry class. This is Revision Uganda. Our aim is to transform a learner from impossibility to possibility. Our website is revisionug.com. Please try to check on it, where you'll find well-organized notes and quizzes for various subjects. And again, don't forget to subscribe to our YouTube channel to get the latest updates and videos. It is Revision Uganda. As now, our chemistry class today, we are going to look at nitrogen and its compounds, and we are going to look at nitrogen as a gas. From senior 1, we looked at air, and we said that air is a mixture of gases. The gases we listed down there, we had oxygen, we had nitrogen, there was rare gases, and also carbon dioxide plus a varying amount of water vapor. So today basically we are going to discuss nitrogen as a gas and nitrogen as an element. So before going into any other thing, let us look at the position of nitrogen on a periodic table. This nitrogen, it is an element. It's an element with a symbol of N. It has an atomic number. Remember, we said atomic number is the number of electrons or protons an atom has. So it has an atomic number of 7. This makes its electronic configuration, whereby when we say electronic configuration, we mean electronic configuration. This means the arrangement of electrons on the energy levels of an atom. So the electronic configuration of nitrogen becomes 2, because the first shell takes 2, then the second takes 5. So this makes the total of 7. So it is 2 to 7, and then this makes nitrogen to belong to a period of 2, because it has 3 energy. It has 2 energy levels. As then it will be in group 5 on a periodic table. Now if you look at its electronic structure, electronic structure, that to show how the electrons are arranged, then we have our nucleus, this one. Then the first shell always accommodates 2 electrons. We can use dots to show them, that one and this one. Then the next energy level from the first one, it accommodates 8, but because nitrogen has 5, then we have a 1 here, then 2, then 3, 4, then we come back and pay a 5. So this is the electronic structure. So this electronic structure makes its valence to be a 3. Why valence? It is defined as the number of unpaired electrons on the outermost shell, or the number of electrons that take part in a chemical reaction presented by an atom. So that is nitrogen as an element. So let us look at occurrence of this nitrogen. So how does it occur? So this nitrogen, it occurs as one. It can occur in a free state, and also it can occur in a combined state. Then in a free state, it occurs as a gas, and this gas is a diatomic gas. It occurs as a diatomic gas. Diatomic means it has 2 atoms. 2 atomic atoms. So nitrogen atom plus a nitrogen atom, we get 2 nitrogen atoms. Therefore, this is the formula for nitrogen gas. So it is a diatomic gas. Then it is found in air. Then in that air, it occupies 78%, meaning that it is the largest part of air. It occupies the largest part within the air in the atmosphere. Then this nitrogen can occur in a combined state. So it can be found also in a combined state. In a combined state, it is mainly found in the proteins, the eggs, the beans, the meat we do eat, and so on. So all those proteins contain a nitrogen element and nitrogen, and also it can be found in what we call nitrates. We have nitrates and also we have nitrites. So, and majorly in nitrites because they can break down to give us nitrogen. For example, we have ammonium nitrite. So we have ammonium nitrite. So there is nitrogen, even this one is nitrogen. Then we can get sodium nitrite also. This is nitrogen, but this N is not nitrogen. This one is one symbol for sodium. So from there, after we have understood the position, the occurrence, and a few things about nitrogen as a gas, let us move on and see how can we prepare this nitrogen. So let us continue with now preparation of nitrogen gas. Preparation of nitrogen gas. So now we've said this nitrogen is found in the air as a free state as nitrogen, a diatomic gas. So we can prepare it from the atmosphere. Even we can prepare it within the laboratory. So there are two methods of preparing. We can prepare this one on a large scale. When we need it in large amounts on a large scale, it can be prepared. So when we are preparing nitrogen on a large scale, we use what we call fractional distillation. Fractional distillation of liquid air. So what is liquid air? So when we go back to air, we said we have nitrogen, there is oxygen, carbon dioxide, and rare gases. So during the process of fractional distillation of this liquid air, nitrogen, carbon dioxide, water vapor, and other impurities are removed. Then remain with only oxygen gas and nitrogen gas that are put into a compressor and they are compressed into the liquid. So what we call liquid air is a mixture of oxygen and nitrogen. So all of them, they're in liquids, then we distill them, meaning that each one has a different boiling point. That's why it's easier to separate nitrogen liquid from oxygen liquid, because these two liquids have different boiling points. Thus fractional distillation of liquid air. This one applies on a large scale. And then we can also prepare it in our laboratories. So it can be prepared in the laboratory. So in the laboratory we use two methods when we are preparing it. One, we use what we call isolation from air. We can isolate it from air, isolation of nitrogen from air. And two, there is what we call thermal decomposition. When I say thermal, it is heat. So decomposition, breaking. So we break down, we heat something and it breaks down into nitrogen. What's that one? It is the ammonium nitrite. So thermal decomposition of ammonium nitrite. Out of all the nitrites, we use ammonium nitrite because it is unstable. Then let us start with this one, isolation from air. So let us see preparation of nitrogen using isolation method from air. So to isolate, so to remove it from air. So let us see, what do we need? The reagents we need here are: one, we need copper tannings. We shall need copper tannings. That is one. And two, we shall need concentrated sodium hydroxide. Sodium hydroxide. Then there is a reason as to why each reagent is needed. Let us start with copper. Let us see the role of copper tannings. Why do we need copper? But remember, these copper tannings must be put in a combustion tube or a furnace. Then they are heated. Then once they are heated, then they are going to do what we are going to see. So the work of, or the role played by the copper tannings during the preparation of nitrogen from using isolation from air, they are there to absorb. For them, they absorb oxygen. They absorb oxygen by oxidation process or method. The copper tannings will react with oxygen, thus removing it from the air. So let us see the equation. Okay, let us see now the equation for the reaction. We've said copper tannings, this is copper cupra. It's a solid. It's going to react with a gas. Remember that gas is oxygen and it is a diatomic gas. Then we are having combustion, that is burning, then it's going to produce a solid, that is copper 2 oxide, a solid. And then this is, we are going to balance copper 1, oxygen atoms, there are 2, here we have 1, so we have to put a 2 here. The moment we put a 2 here, copper becomes 2, oxygen 2, then oxygen 2 and 2 here, but copper is not balancing, we also put a 2 there. So that is the equation for the reaction. Then there is what we call an observation. So there is an observation we made. This is copper as a solid, so it is a brown solid, then reacting with this colorless gas which we can't see, then it's going to produce a solid. Then this solid is going to be a black solid. So observation made, 1, the brown solid reacts with oxygen to produce a black solid, and this black solid, it is the copper 2 oxide. Then the brown solid is copper, then after reacting with oxygen, then it becomes a black solid, that is copper 2 oxide. Then another reagent that was concentrated sodium hydroxide. Then why do we use it also? Then this one, it is used to absorb carbon dioxide. So to remove carbon dioxide, remember this nitrogen is being removed from air, from the atmosphere, so it comes with the oxygen, it comes with the nitrogen, it comes with the some water vapor and also other impurities plus rare gases. Thus we have to use sodium hydroxide in order to remove carbon dioxide. Then let us see the equation for the reaction. So we are having sodium hydroxide. So this is sodium, then hydroxide, they are all in valence 1. So this is aqueous. Then it's going to combine with carbon dioxide, which is a gas, and again it's going to produce a sodium carbonate plus water. Then this is a liquid, so sodium carbonate plus water, so we are balancing, so we put here 2 in order to balance sodium. So sodiums, there are 2, even here there are 2, oxygens here there are 2 plus these 2, they are 4 now, then these 3 and this 1, then hydrogens now they are going to be 2, then hydrogens here there are 2, so the equation is balanced. But this equation is obtained when carbon dioxide is little. This one is obtained under little carbon dioxide supply. But again, if carbon dioxide is in excess, so if it is in excess, what are we going to get? We are now going to get this sodium carbonate plus this water plus more carbon dioxide, or I can start from sodium hydroxide plus carbon dioxide, then I get one compound. Before going into excess, we have to start with a little, then you keep it keeps on coming. That's when we are going to get sodium hydrogen carbonate. So if it is in excess, now it has to first form sodium carbonate, carbonate here plus water. Then we add in more carbon dioxide, which is now in excess, which is a gas, so it's going to form sodium hydrogen carbonate as one compound. Then sodiums, we have to balance the sodium. If I put here 2, then sodiums are going to be 2, even here there are 2. Carbon, they are going to be 2, this carbon here and this carbon from carbon dioxide now, and this, it will affect this carbon, they are going to be 2 now. Then this oxygen, we have 3 of them, then plus this one, they are 4, plus these 2, they are 5. These 3 plus this one, they are 4, plus these 2, they are 6. Then these 2 times this one, these 3, they are also 6. Then hydrogen, they are 2, even here they are 2. Thus the equation is balancing. Now let us look at some notes here. There are some notes we are going to make, important notes we are going to make. Let us start with the gas obtained. The gas obtained is going to be collected. How would we collect it? We are going to collect it over water. And why do we collect it over water? It is slightly soluble. It does not dissolve in water, just it bubbles out, so it is slightly soluble in water. That is number one. Note 1. Then note 2, this gas obtained, it is impure. It is not, it is impure. So once it is impure, it becomes denser. And why is it impure? It contains some dust particles, because we are using isolation from air. So the air comes with the impurities, the dust, and so on. Then again, it contains rare gases, mainly the argon, and this argon cannot be removed from this nitrogen. Why? This gas is inert. For them, they don't react with anything, so they are inert. That's why it is difficult for us to separate argon, which is part of air, from the nitrogen we have collected. Then let us look at the diagram. So let us now look at this diagram. So this diagram you are seeing here, it is showing us the preparation of nitrogen from the air, isolation from air. So we are having this one we are going to call it the aspirator. Aspirator is like something respiring, aspirator. Then here we are going to have our solution, then meaning that from here we are having this furnace. This is the combustion tube. Here it is the furnace, the combustion tube. Then these are the delivery. This is a delivery tube. Now this is a water trough. This one is a trough. Then this is a beehive shelf. Beehive shelf. This one. Now, so here we are having a tap. So this tap is going to provide us with water. Then this water is going to be poured into this aspirator. Then this arrow is showing us water entering. Now this arrow is showing us air going out. The reason as why we are using this tap water is to force out this air, because this space you are seeing here, it is filled with air. Then as we use this tap water, then this tap water is going to force out the air from it. Thus the air will move upward here. Then it will be now dropped into the second bottle containing concentrated sodium hydroxide. And if we don't use sodium hydroxide, we can use potassium hydroxide. Then the importance of this one is to absorb what we call carbon dioxide. Then after that, this air, because if you keep on putting in tap water, then air will be forced. Then that pressure will force this air also after passing through sodium hydroxide. Then it rises from here. Then it will just go up here. Then this air which is here now, it contains oxygen. Here it contains oxygen. Then carbon dioxide has been removed, and nitrogen plus rare gases. Then on reaching here, here we are having the copper tannings. So the copper tannings are here. So these ones are copper tannings. So they are being heated at red hot. Then as this is passing over this, then oxygen will keep supporting the copper tannings, thus being removed from the mixture. Then in this delivery tube now, we are going to receive nitrogen plus rare gases. Nitrogen gas plus rare gases. Then it's going to be collected over water. So here we have now collected our nitrogen. So this is a diagram showing preparation of nitrogen from air. Then again, here we have to make one note, and this note, it is about this copper. If we change, instead of using copper tannings, and we use magnesium powder, what are we going to see? We are going to see changes. One, we are going to receive less nitrogen. So the nitrogen we receive as we are using copper, it is going to be more than that we are going to receive if we replace copper by magnesium, simply because this magnesium, it is very reactive. It is so reactive, meaning that it will react with nitrogen. As it reacts with the nitrogen, it will reduce the volume we are going to collect over here. So it will be now this magnesium as a solid will react with the nitrogen as a gas to give us magnesium nitride. So In so doing, we are now going to reduce on the amount of nitrogen we are going to receive over here. So to balance the equation, we have 3 magnesiums because nitrogen is in valence 3. Then the 3 comes here, nitrogen is balancing. So I hope you've understood that very well with the notes that are taken. And again, another note here, if we want this gas dry, we can pass it over or through what we call drying agents. And we have 2 drying agents here we are going to use. One, we can use concentrated sulfuric acid, this is the formula, or we can use anhydrous. So this word must be there, anhydrous, meaning it is dry, does not have any water. Anhydrous calcium chloride. We can, if we want this gas dry, so if it is now dried, then we collect it using a syringe. So let us move on and see another method of preparing nitrogen. So here with me again, we are still looking at nitrogen as a gas, and we are looking at its preparation. Briefly, we said we can prepare it in the laboratory and on a large scale in factories. So by manufacturers using fraction distillation of liquid air. In the laboratory, we've seen using isolation method from air, using copper tannings to absorb carbon dioxide being absorbed by sodium hydroxide concentrated or potassium hydroxide. And we said if we need this nitrogen dry, we use drying agents as concentrated sulfuric acid, and also we can use anhydrous calcium chloride. Then here we are going to look at another method of preparing nitrogen in the laboratory, and this is what we call thermodecomposition. Thermodecomposition of ammonium nitrite. This is ammonium nitrite. And now with this thermodecomposition of ammonium nitrite, it is not direct. It's not a direct reaction in that we don't just get an ammonium nitrite and we just heat it. Why? This ammonium nitrite, once it is heated, it can explode. If it is heated alone, it can explode and cause accidents. Thus we need to use other reagents, and here we use 2 reagents that are going to give us ammonium nitrite because it is unstable nitrite. So one, we are going to use ammonium chloride, that's one, and again 2, we also use a sodium nitrite, meaning that this sodium nitrite is going to provide us with the nitrite, and ammonium chloride is going to provide us with the ammonium. Then we make ammonium nitrite. Then this reaction occurs in 2 steps. It is a 2-step reaction. It occurs in 2 steps. Step number 1, that is the reaction between sodium nitrite plus or with ammonium chloride. They are all aqueous. Then we are going to get ammonium. Then we are going to get ammonium nitrite. Then plus sodium chloride. Then to balance this one, sodium 1, nitrogen, this one plus this, there are 2. This one plus this one, there are 2. Hydrogen, there are 4. We have 4 here. Chloride 1 and also 1. So that is our step number 1. We have produced ammonium nitrite. So ammonium nitrite is unstable. It is unstable, whereas sodium chloride is now stable. On heating, now the second step, on heating, this sodium chloride will not decompose, but now this ammonium nitrite is now going to decompose. The reason as to why we are using this, it is this sodium chloride which is stable will prevent the ammonium nitrite from exploding, so it will just decompose slowly. So we shall have now the second step here, the decomposition of ammonium nitrite, which is ammonium nitrite here, and it will decompose to give us nitrogen as a gas plus water. So to balance the equation, so we put here a 2. So there are 2 nitrogens. Here we have 2 nitrogens. Sorry, we have 2 nitrogens, then 4 hydrogens, then we put here a 2 to balance our water. This is a liquid and this is a gas. So we have looked at the preparation of nitrogen using the two methods, isolation and thermal decomposition of ammonium nitrate, and we've said ammonium nitrate is not decomposed alone, it can explode. So it is we use other reagents as ammonium chloride with sodium nitrite to provide us with the ammonium nitrate, which will now decompose to give us nitrogen gas and water. So in this flask here, it's having a mixture of now ammonium chloride plus the sodium nitrate. Then we have to heat. On heating, we are going now to produce ammonium nitrate plus sodium chloride. Second step, the sodium chloride is stable, will not decompose. Then the ammonium nitrate will decompose into nitrogen and water. Then this is a delivery tube. Then nitrogen is going to be collected over here. So once we need it dry, we just pass it through drying agents as we discussed them earlier, and we collect it using a syringe. So I congratulate you for choosing Revision UG. Please keep on following our website, which is revisionuganda.com. You'll find well organized and summarized notes and quizzes to attempt. So let us meet in the next lesson looking at ammonia and properties of nitrogen gas.